Hello, I'm Ryan Kinchin with High Desert Math Tutor, and today I want to talk to you about polar coordinates. So before we get into the polar coordinates, let's talk about our usual coordinate system that you probably grew up with. So the official name for the traditional coordinate system that we're used to is actually the Cartesian coordinate system, but based on the grid that we use, it's often called the rectangular coordinate system also. So let me give you a quick example. In the Cartesian coordinate system or the rectangular coordinate system, we always have an ordered pair that starts with x, then y. So an example here, we could say x is 3 and y is -4. What we do is we start at the origin, we move over to where x is 3, so we go 3 steps in the positive x direction. After that, we go 4 steps in the negative y direction. So we'll go 1, 2, 3, 4. This is where our final point would reside. So this point right here is 3, -4. So that should be familiar for us if we're moving on to polar coordinate systems now. Now, just as we have an ordered pair here, so let me write that in. So we have ordered pair in our Cartesian or rectangular coordinate system. The order of the numbers we write in the parentheses is always going to represent the x value, then represent the y value. In the polar coordinate system, things are changed a little bit. So polar coordinates it's a coordinate system that's designed to work nicely with circles. So often when you get to math, say in trigonometry, sometimes geometry, we start to talk about shapes that really focus on circles, and we realize that the most natural coordinate system is not a rectangular coordinate system when we're talking about circles. This is where the polar coordinate system comes in. So in circles, what do? You're always rotating. So rotations we describe using angles. Now, what else does every circle have? By definition, every circle has a radius. So we took advantage of those two components when we came up with or constructed polar coordinates. So in the ordered pair for polar coordinates, instead of having an x value and a y value, for polar coordinates, we have a radius that we want to go out from the center of some circle, and we have the direction that we want to be pointing. So for the sake of simplicity, I'm going to go ahead and talk with degrees when we're talking about angles today, but pretty commonly when you're talking about polar coordinates, either in more advanced algebra, trigonometry, or calculus, you're typically always going to be talking in terms of something called radians. But again, today we're going to talk about degrees. So let me give you a quick example. So I could tell you I want a radius of 3, and I want to move an angle of, say, 45 degrees. Now, how this works, just like any other time you're looking at angles on a set of coordinate axes, we always start by facing the positive x direction. So you want to imagine that we're starting with an arrow facing in the positive x direction. Now from there, we are going to first turn to 45 degrees. So we're going to start here, we're going to turn up to 45 degrees. Now facing in that 45 degree direction, we want to go out from the origin. We want to go out 3 steps. So each of these lines, as I said, polar coordinates focuses on circles. Each of these circles represents 1 step out from the origin. So we first point in our 45 degree direction, then we go 1, 2, 3 steps out, and this is where our point goes. So right here, we have the radius, the angle. So the radius is 3, the angle is 45 degrees. Now let me give you a second example before we kick it up a notch and get to something that confuses people a little bit initially when we're talking about polar coordinates. So now let's look at, say, a radius of 2 and an angle of 90 degrees. So, as always, we'll start by facing the positive x-axis. But what is the angle we are going to be turning now? Well, the angle we're turning is 90 degrees. So from here, we're going to turn so that we face 90 degrees. Then what is the radius? So from the origin, we're going to now go up towards 90 degrees 2 steps. So now we're going to face up 1, 2, and that's where our point goes. So here, I'm just going to put the actual point in polar coordinates to 90 degrees. Okay, so you're with me so far, right? So we always start by facing the positive x direction. We're going to turn in the direction that this angle tells us to turn, however far we're supposed to turn. Then we're going to go out this far from the origin. So let me give you 2 examples now that could be a little bit confusing. So the first one, I'm going to use a green marker. We are going to turn not in the positive direction, but we're going to turn in the negative direction. So let's say we want to go still 2 steps out from the origin, but we want to go in the negative direction 90 degrees. So remind me, what direction are we starting facing? What's our initial direction? The initial direction is the positive x-axis. And as you may remember, when an angle is negative, that means we turn in the clockwise direction. And how far are we turning? 90 degrees. So we're starting by facing the positive x direction. We're going to turn in the clockwise direction, 90 degrees. And now we're going to go out 2 steps from the origin. So we're going to go 1, 2 steps out. This is where our point resides. So 2, negative 90 degrees. Now my final example that I want to give you, and this is the one that confuses people the most. I want to talk about having a negative number for the radius. And for simplicity, I'm going to keep a positive number for the angle. So I'll give you 2 examples of this. But the first things first, we should talk about radius being negative. Can a radius be negative? So the thing that we need to recognize that is often not talked about in more beginning math classes is that negative numbers have 2 components. First, there's the negative, then there's the number. Those 2 things are actually separate. They tell us 2 different pieces of information. So a number here tells us how far we want to move. But the sign, the positive negative sign of this number tells us which direction we want to go. So in polar coordinates, as we've seen, we need to think about this as if we have an arrowhead facing out in a certain direction, then we're going to turn to an angle. Well, now what we want to say is if the radius is positive, we move in the direction of the arrow. But what's new is what if our radius is negative? Well, if our radius is negative, so if the radius is negative, we move in the opposite direction. So we move in the opposite direction of the arrow. So you can think of this sort of as just going backwards. Positive means go forward, negative means go backwards. So let's look at this example. So first things first, I'll use green once again. Well, no, I'll use red, I'm sorry. So here we see this is red. So the angle we're facing is 0 degrees. So we start by facing the positive x-axis, and we are going to turn 0 degrees, which means we don't turn. But now we think about our radius being -3. -3 says we are going to go 3 steps in the opposite direction as the direction we're pointing. So if we're pointing to the right, we want to go 3 steps to the left because that's the opposite direction. So now we're going to go 1, 2, 3 steps in the opposite direction that we were pointing. So right here, this point can be described as -3, 0 degrees. So I'll give you one more example. So this last example, let's go ahead and use green. I want to go 4 steps out in the negative direction of the direction we're pointing. And I want to turn to an angle of, let's say, 135 degrees. So let's begin by facing in the positive x direction. Now we're going to turn to 135 degrees in the positive direction. So from here, we're going to turn positive counterclockwise direction, 135 degrees, which is pointing this way. Now notice our radius is negative. What does it mean if the radius is negative? It means we are going to go 4 steps in the opposite direction that we're facing. So we're facing this upper left direction. We need to go the opposite direction, which means we're going to go down and to the right 4 steps. So now we'll do that. So we're going to go 1, 2, 3, 4 steps in the opposite direction. So the description of this point can be -4 and 135 degrees. So just a quick recap. The 2 common coordinate systems that you use in 2-dimensional spaces. The most familiar one is the Cartesian coordinate system, also known as the rectangular coordinate system, because the grid that we have with graph paper is rectangular. But this new coordinate system, which we like to use with circles or circular situations, is called polar coordinates. So again, polar coordinates, we're thinking about circles. So we have an array of circles on a polar coordinate graph or polar coordinate graphing paper. In rectangular or Cartesian coordinates, we use an ordered pair where the first number is an x value, the second number is a y value. But in polar coordinates, our ordered pairs, the first number is a radius, the second number is the angle of the direction we want to face. But in polar coordinates, it's possible for our radius to be negative, but it's not so much that it's a negative number, because a distance like a radius cannot be negative per se. But what we have here is the distance that we want to go out from the origin, and the sign of the radius, positive or negative, tells us if we want to go forward in the direction we're looking, or if we want to go backwards in the direction opposite of where we're looking. So if the radius is positive, we're moving in the direction that our arrow is facing. If the radius is negative, we move backwards, the opposite direction that the arrow is facing when we turn to this angle. So I hope that makes sense. I'll come up with more videos in the future. The next one will probably focus either on using polar coordinates in radians, or we'll make another video more advanced for calculus where you talk about rectangular, polar, and spherical coordinate systems.